My name is Enrico, and this video is an introduction to a landscape analysis of 10 general-purpose compute frameworks. The ultimate goal of this survey is to highlight the pros and cons of existing technologies and hopefully help our community to build a modern framework. This analysis includes the following parts: a walkthrough of each framework and a discussion on how they're positioned in the compute space, and a collection of code snippets to show you their APIs and give you a way to compare them without installing the whole thing, and a reproducible benchmark to study their behavior in processing a large data set. Do note that the full analysis is available in the accompanying slides and the code repository, so please follow those links if you want to learn more details about this work. And let's just begin with the introduction then. The landscape of compute techs is vast. There are countless of solutions out there using different underlying technologies. In the Python world, you find pandas and Dask. They process data on the fly, meaning that they load data just when it's needed. Became popular in the data analysis world thanks to their high-level APIs. Provide you with a data frame structure that is just great for handling tabular data. Then we have database systems like Postgres and Snowflake. This strength lies in the fact they provide both data storage and processing. Now, this is different from the previous group. Thanks to this, they perform well because they can optimize the way data is stored on disk. The third group is the big data family with Apache, Spark, and Hadoop. They're famous for their capability of storing and crunching huge datasets in clusters that count up to thousands of nodes. Differently from the previous group, they tend to tackle a wider range of use cases, including structured and unstructured data, batch and streaming processing, and so on. This, of course, comes at the expense of carrying more complexity under the hood. Last but not least, there is a number of Web3 technologies trying to combine distributed storage and compute. Some are more developed than others, but in general, these techs really need more maturity to grow big. Having introduced the technologies, let me point out a few critical issues we found among them. Generally speaking, the more scalable a framework is, the more its complexity tends to grow, and sometimes this occurs exponentially. This is not just about writing articulated code, it's about debugging, packaging a job, launching it. All this can be very complicated. And notably, some frameworks are also quite complex to set up and maintain as well. In the landscape analysis slides, you'll find more detailed discussion about these issues. But overall, let me just say that developers usually just want to focus on their code. We think a modern framework should do its best to achieve that. And regarding the tools mentioned above, there's definitely lots of room for improvement. This landscape analysis includes a collection of code snippets that wants to show you how a processing job looks so different across platforms. For instance, let me quickly show you how a word count job looks like in Snowflake. As you see, it's just a nested SQL query. Differently, Hadoop implements this using a more lengthy MapReduce paradigm, which, as you can see, it's far more complicated. Now, hopefully going through the collection of available examples on the repository will help you quickly grasp more on the differences between these frameworks, at least in terms of API. Well, we also benchmark the performance of these frameworks in processing a large data set. The scripts are provided with the repository along with the installation instructions. By the way, going through the multi-node installation is rather instructive for a first-hand experience. You'll learn the hurdles involved with installing complex frameworks such as Hadoop. Back to the benchmark task, it is a word count job on large dataset containing almost 2 billion words. The job requires the compute engine to output how many instances there are for each unique word. Remarkably, only Spark managed to complete the task in a few seconds. And by taking a deeper look at the resource use, I can tell it's very efficient in doing so. So given this and the fact that its setup is relatively easy, I would recommend looking at Spark for drawing some inspiration for future works. I cannot stress enough how important it is for modern framework to deliver ease of use end to end. Please find more thoughts on these in this section right here. I hope you enjoyed this intro video, and I thank you for your attention.